Okay, so here we have a graph where the x-axis has acceleration, in which the units are meters per second squared, and the y-axis has force, which is measured in newtons, and that is represented through the variable n. So we figured out that the slope of, well, what my group got from our lab was that the slope of the line in this graph is 1.2 newtons over 1 meters per second squared. And what that means is that for every meters per second squared, for every acceleration meters per second squared, the force is increased by 1.2 newtons. And we also got a y-intercept, which is 0.07, and I think that would be somewhere around here. And what the y-intercept is that when the acceleration is at 0, then the net force is 0.07 newtons, which is almost 0, since if you have an acceleration of 0, then you have a net force of 0. So the y-intercept really doesn't matter. Sorry. The y-intercept really doesn't matter because 0.07 is already close to 0. So, we also found out that this right here, 1.2 newtons, can be the weight of the car that we use in the lab. Anyways, as I was saying, we figured out that this 1.2 newtons up right here in the slope, it can actually be the mass of the car. And how we determine that is if we put it into this, I think it was called Newton's second law, where net force is equal to the mass times acceleration, in which the mass, of course, is this right here, the slope. So, if we take 1.2, okay, let's just assume that 1.2 newtons actually was the mass of the car. Let's just assume that it was 1.2 kilograms, because that's how you measure the car, in kilograms. So, we have 1.2 kilograms, and for acceleration, we multiply that with 1 over meters per second squared. And if we do the calculations right, then it should all convert to this net force should be equal to 1.2 newtons.